Hi, it's Ms. Marsden. I'm going to go through a lesson with you today on atmospheric pollutants. So, first task which you have in front of you should have your booklet for this week, either the foundation one if you're in set 2 or 3, or the higher one if you're in top set. So, do know questions are related to everything that you've done so far. This might be last week or it might be earlier on in the year. Just a quick pointer that for question 2, the atomic masses have been given to you for what you need for methane, which is CH4. But if you do want to have a go at the stretch task, there's a periodic table in the folder for this week's work, and you can use that to find out what the atomic mass of oxygen is. Remember that when you're looking for atomic masses, you're looking at the bigger number on each element on the periodic table. So pause the video for as long as you need to have a go at all the do now tasks. And we're going to mark these on the next slide. So you should have completed the do now questions. So what you need now is a different coloured pen. Your 3 greenhouse gases that we talked about last week, carbon dioxide is the main one which we usually discuss, but you also need to know methane and water vapour as well. So for relative formula masses, like I said, the atomic masses for carbon and hydrogen were given to you. So we have 1 carbon, so we do 12. And then hydrogen, we have 4 hydrogens. So you need to add that to 4 like the working out shows. And if you want to do the same thing for carbon dioxide, you have 1 carbon, which is 12. And then there's 2 oxygen atoms, so you do 16 times 2. You add those together and that gives you 44. So give yourself a mark out of 5 for that and improve any which you did not get. My advice would be to put them into full sentences so you're really thinking about how to improve your knowledge next time. So outcome for today's lesson is to be able to predict the products of combustion, to describe how carbon monoxide, soot, sulfur dioxide and nitrogen oxides are produced and released into the atmosphere, to describe the problems that these pollutants cause. So, burning fuels. So we always talk about carbon dioxide as being a product, but actually there are other products that we need to know about, and we need to know how to categorise them as well. Each of them have separate impacts on the environment, so we're not always just talking about the greenhouse effect and climate change. So, in terms of carbon dioxide, we also need to know about carbon monoxide, soot, which is solid carbon, and we can also call that particulates as well. We need to know about sulfur dioxide as well as nitrogen oxides. So, if we use an example of a fuel, a common example is methane, which is CH4. That's known as a hydrocarbon because it's obviously made out of hydrogen and carbon. And whenever hydrocarbons are burned, the 2 main products are carbon dioxide and water vapour, which are 2 examples of greenhouse gases. Another word for burning is combustion, and it requires oxygen from the air. So when methane, which is CH4, burns in a Bunsen burner, it reacts with the oxygen in the air to produce carbon dioxide and water vapour. And like I said, both those products are greenhouse gases, so we can link that to what we've learned in the topic so far. So when we're talking about combustion, which is burning, we have 2 types. We're going to talk about complete combustion first, and that's where you have plenty of oxygen, so all of the fuel is able to burn. For example, the blue flame of a gas hob, or that on a Bunsen burner, is an example of complete combustion of a hydrocarbon, because all of that fuel is being combusted. The products are always the same, so we always have the hydrocarbon reacting with oxygen to produce carbon dioxide, water vapour, as well as energy. So, on the flip side, we have something called incomplete combustion. What you can do is pause the video to think what might incomplete combustion be, and they can then compare it to what actually is the definition for incomplete combustion. So incomplete combustion occurs when there is a shortage of oxygen to when a hydrocarbon is being combusted. So you'll have seen this with the Bunsen burner, and that's what causes the difference between the flames when the air hole is open versus when it's closed. So if you remember, when you light a Bunsen burner, if the collar's open, then the flame will be orange, whereas, oh, wrong way around, it'll be blue, but when it's closed it'll be orange, and that's because the oxygen isn't getting to it. So if we look at the two equations, and we're not looking at methane anymore, we're looking at heptane. So top one is showing us complete combustion. What I'd like you to do is to compare that to what is being produced in incomplete combustion. So just pause the video and have a go at labelling what is being produced in incomplete combustion. So reaction 2, which is incomplete combustion, there's less oxygen being used. We've got 7 molecules compared to 11. There's carbon being produced in reaction 2. There's also carbon monoxide being produced, which is not produced in complete combustion. There's also much less energy produced as a result of reaction 2, which is incomplete combustion. So any points that you didn't get, please add them in a different colour, and any corrections that you need to make, please do. So in incomplete combustion, it's just more to remember. So you still have carbon dioxide and water, but you also have carbon monoxide, and you have soot as well, which is solid carbon. It's really important to note that there is less energy being produced as a result of incomplete combustion. So carbon monoxide, you might have heard of it, it's a toxic gas, and it's so toxic because what it does is it binds to red blood cells, and that prevents oxygen from being carried around. And what you should know from biology is that our oxygen is really important for respiration. So soot are small particles of unburned carbon, so it's solid particles. And what I'd like you to do is I'd like you to use the two pictures to have a go at telling me what are the problems caused by particulates. The problems are they can cause something called a global dimming as they enter the atmosphere, and that's basically smog. It causes sunlight to become dimmer as a result of scattering through these particles. And they also cause health problems when they're breathed in, and that can be asthma attacks for people who are asthmatic, lung cancer, for example. So this is a bit of a knowledge check. What I'd like you to do is, can you predict the product of the following reactions and have a go at using symbols, not words? For example, CO is carbon monoxide, CO2 is carbon dioxide, and C is your solid soot or particulate. We'll go through one together. So methane burning in a good oxygen supply. Notice how good is underlined. So would that be incomplete or complete combustion? It would be complete combustion because there's a good oxygen supply. So I'm going to have CO2 and H2O produced. Have a go at the next one. So that's the same. You're going to have CO2 and H2O. And that one's a demonstration of incomplete combustion because there's a limited oxygen supply. So you should have said CO, which is carbon monoxide, C for soot or particulates, which is your solid carbon, and water vapour as well. Next one. So again, that's complete combustion, so you have carbon dioxide and water. Next one. So that's incomplete combustion, so you have carbon dioxide, carbon and water vapour as well. The next one. Oh, that's all of them. There we go. So, next task in your booklet, please. You've got a table, and that's got a list of pollutants, all of them which we're going to cover today. But what you need to do is a summary of the three we've covered so far, which are carbon dioxide, carbon monoxide, and particulates. Can you please tell me when and how it's produced in terms of incomplete or complete combustion? And then can you please give me a description of the problems that it causes in the table? Keywords to use are at the bottom. Please make sure that you do and that you highlight them. And pause it for as long as you need to. I'm going to go through the answers on the next slide. So, compare what I've got in my table to what you've got. So carbon dioxide's a product of complete combustion, and the problems it caused are what we've been talking about for the last couple of weeks. So greenhouse gas, it's a greenhouse gas, so it links to the greenhouse effect and causes climate change. Carbon monoxide is some new knowledge for today, so that's a product of incomplete combustion. It binds to red blood cells and it's poisonous because it prevents oxygen from binding. And then your soot is a product of incomplete combustion, and that's linked to global dimming and lung disease. So double check you've got all that knowledge. So the last two products we need to talk about are sulfur dioxide and nitrogen oxide. So when we talk about fossil fuel, there's very small quantities of sulfur within them. When fossil fuels are burned, the sulfur reacts with the oxygen in the air to produce sulfur dioxide. Sulfur dioxide is a gas, but what it can do is it can dissolve in rain clouds to make sulfuric acid, and that sulfuric acid, like in the diagram, falls as acid rain. The word equations there, so we have sulfur and oxygen, and that produces sulfur dioxide. So nitrogen oxide is very similar. It's not formed by the fuel itself, it's formed from the reaction of nitrogen and oxygen from the air, and that's inside hot engines. So engines in a car get very hot, and this catalyses this reaction to happen. So the nitrogen oxides react with water in the air again to produce nitric acid, and that falls as acid rain. You can see from the diagram that the areas in red are the most acidic, so the east of England is higher affected than we are. So remembering that a lower pH is more acidic. What's the problem with acid rain? Actually, the problems with acid rain are, you can see from the diagrams that it damages leaves on trees, so they can't photosynthesize. And if acid rain falls on water bodies, so lakes, too much, it can become too acidic for the organisms that live in it, and you can see that it has a negative effect on the living things in those areas. What I'd like you to do is, same thing on the table we've just completed, I'd like you to tell me for sulfur dioxide and nitrogen oxides, when is it produced and what problems do they cause? So pause the video for as long as you need to. Check your answers. So sulfur dioxide is coming from the sulfur in fuels reacting with oxygen, and it forms acid rain. You can be really specific and say acid rain brackets sulfuric acid. And nitrogen oxide is slightly different. It's the nitrogen in the air reacting with oxygen, and that's happening in hot engines in cars. But nitric acid is formed from nitrogen oxides, not sulfuric. What I'd like you to do is, using your knowledge from today, I'd like you to use the diagrams as well to make a list of the environmental costs of fossil fuels Obviously, we know from the last couple of lessons in terms of the effects of the greenhouse effect and climate change, but I'd like you to add anything extra which you've learned in today's lesson. So you should have talked about the impact of acid rain on the trees there. So climate change is linking to the changed weather patterns as a result of the greenhouse effect. And you can talk about ice caps melting as a result of that. And the increased temperatures affect coral reefs as well. That's what we talked about last lesson. So what can we actually do about the effect of burning fossil fuels? We've taken steps in it in terms of removing sulphur from petrol, so that's reduced the amount of sulphur dioxide being released. But also power stations which burn fossil fuels have adapted the chimneys which remove sulphur and nitrogen before it's released into the environment, which reduces the effect of acid rain. So last task for today, you've got a learning check, and what I would like you to do is to answer the 10 questions which we're going to mark together on the next slide, and that's based on the learning which has taken place in today's lesson. So I'd like you to mark your answers in a different colour. So combustion simply is burning. Carbon dioxide and water are produced in complete combustion for number 2. Please be specific for number 3 and say not enough oxygen. To say not enough air is not sufficient. In incomplete combustion, we still have carbon dioxide and water, but we also have carbon monoxide and carbon. You could have also said soot or particulates. For number 5, sulphur dioxide is produced when sulphur reacts with oxygen. Number 6, nitrogen oxides are formed inside hot engines. Please be really specific and say hot engines, because it's the heat that's important. The nitrogen and oxygen come from the air. You should know that from the beginning of the topic, that 78% of the atmosphere is nitrogen. Sulphur dioxide and nitrogen oxides cause acid rain, and you could have gone into more detail about the effects of acid rain in terms of trees and bodies of water. Notice for number 9, we have environmental problems caused by particulates. So you had to say global dimming. If it said what problems are caused by soot or particulates, you could have said lung problems as well. And carbon monoxide is so dangerous because it binds to red blood cells where oxygen should bind. And for higher level, you could have also said that prevents respiration from happening. So stretch test for those of you who want to have a go at it, you can complete the remaining exam questions. When you've completed the remaining exam questions, the mark schemes are also in the folder, so can you please make sure that you are marking your answers using the mark scheme so you can improve on them. There's also a fluency test that you can have a go at as well. And in case you need a reminder that percentage change, you do the change divided by the original value and you multiply that by 100. The mark scheme for the fluency test is also in this week's folder, so please make sure that you're improving your work. Please make sure that you send your completed work to your class teacher and that you complete your Educate quiz for this week. That should be completed by Monday, please.